Analyze the thermodynamic sign of the enthalpy change. Delta H, the given chemical equation, is CO plus 2H2 is in equilibrium with CH3OH with delta H less than 0. A negative enthalpy change, delta H less than 0, indicates that the forward reaction is exothermic. It releases heat. We can conceptually write heat as a product on the right side of the equilibrium. CO plus 2H2 is in equilibrium with CH3OH plus heat. Apply Le Chatelier's principle to the temperature increase. When the temperature of the reaction system is increased from 483 Kelvin to 650 Kelvin, the system counteracts this stress by shifting in the direction that absorbs heat, the endothermic direction. Since the forward reaction is exothermic, the reverse reaction is endothermic. Therefore, the equilibrium will shift to the left toward the reactants. Relate the equilibrium shift to the equilibrium constant expression. Kc, the equilibrium constant expression for this reaction is Kc equals CH3OH over CO, H2, to the power 2. Because the system shifts to the left, the concentration of the product, CH3OH, decreases while the concentrations of the reactants, CO and H2, increase. Mathematically, a decrease in the numerator accompanied by an increase in the denominator results in a smaller value of Kc. Identify the underlying chemistry concept. Temperature dependence of K. The value of an equilibrium constant K depends solely on temperature. For any exothermic reaction, raising the temperature favors the reactants and causes the equilibrium constant to decrease. This explains why Kc at 650 Kelvin will be less than the value of 14.5 measured at 483 Kelvin, making option C the correct answer. The correct answer is option C. Kc will decrease because the reaction is exothermic.